So now that I have some basic functionality inside my scene, I want to go back to my design document and remind myself what some of the other elements are. So my wireframe here calls for the obstacles to be spawning at different heights. And what we'll do is we'll establish sort of we'll establish a random number that's clamped between whatever the highest y value and the lowest y value should be, and we'll use that number, that randomly generated number, to establish the y position of our obstacle each time it spawns. And so the effect will be that as our state machine goes through the process, I'll go back to my spawner. So when this object is spawned, it'll go to the wait period and it'll revisit the spawn and generate a new y coordinate based on limiting it between two values. Now, in order to do this, anytime you have something that's changing over time, or something that you want to add to or keep track of, you're going to establish a variable. Now, a variable, as it implies through its name, is something that's variable in its nature. So if we're tracking a number, that number could be 1, 2, 3, -1, -5. There's different kinds of variables. And we'll take a brief look at some of those variables. And what we'll do is we'll store a randomly generated y value into a variable. So in order to do this, I'm going to go to the variables tab. And this is the nature of variables can be a little abstract at first, but PlayMaker makes it really easy to be very intuitive about the creation of variables. With the variable tab selected, what I'm going to do is I'm going to create a new variable, and I'm going to call it something that makes sense. And this is going to be y position, okay? Or I could have called it random y position or new y position, but I'm just going to call it y position. And the type of variable that I'm going to create, you'll notice there's a whole list of these. Some of these are proprietary to Unity, and then others are typical styles of variables. The primary variables that we want to concern ourselves with are float and int. Int stands for integer, and float is a floating point number. And a floating point number, if you look up here at the position of any object, it could be at the position of 12, or it could be at the position of 4.75 in this case, depending on what position we're looking at. And so 12 is a good example of an integer. 4.75 is a good example of a float value. Now, a float value can equal 12. It doesn't have to have a decimal, but a float value allows for a decimal in its point. Now, it's a little bit more complex. It's a little bit more system resource intensive to use a float versus an integer, but a float is something that will allow us to keep track of decimal points. And so this is something that we want to use for our new y position. So in the variable tab, I'll create a new variable called y position. I'll make sure it's set to float, and I'll hit the add button. And once I do that, I now have this y position, which is a float. It's currently being used 0 times, but we'll use this to store the value of a randomly generated number. Now, when it comes to the number that we're going to generate and store in this variable, I want to get an idea of what my values can be, or what the space is that we can generate this in. So I'm just going to throw in my obstacle just for a moment here. And I'm going to make sure that I'll just reset all these values. Nope, didn't want to do that. Let me undo. I only wanted to reset the position. I can do that by choosing reset position. And I'll move this back. And so I'm not worried about the X or the Z position. What I'm worried about is the Y position. And let's say that I'm just going to move this object around and say, okay, that is as low as I want this object to spawn. I don't want it to spawn any lower than that. And I'll look up here, and the original position of the object was probably pretty close to 0. Okay, so let's just key in the value of 0 to make sure that's about where. Okay, so 0 along the Y looks like an appropriate low spot to spawn. I'll just move this object up, and maybe that's about as high as I want this to spawn, or maybe even a little bit higher. So it looks like 10. If I round this up to 10, that could be the high point of our spawn. So what we want to do is we want to generate a value for y that's somewhere between 0 and 10. And every time this object spawns, to place the Y position of the spawner to this randomly generated Y position. So what I'll do is I'll get rid of my temporary obstacle that I use to kind of measure the space. And I'm going to go back into my obstacle spawner. Now, the first thing that I'll do is I want to generate this random number. Okay, now I could do this either in the state at which we spawn the object or the place where we're waiting for it. It's you know, whatever makes most logical sense. I'm going to just attach everything to the spawn object state. And what I'm looking to do, I'm looking for a math function. And remember, our value was a float value. And if I look in here and say random, I'm looking for a random, and I don't want a random bool and a random integer. I want a random float. I'll double click. And what this action says is establish a minimum of 0, which is exactly what we wanted our minimum to be. And I'll establish a maximum of 10, okay, because I wanted my Y to be somewhere between 0 and 10. And then we want to store the results. So every time it passes through this state, it's going to encounter the spawn object. It's also going to encounter random float. It's going to randomly generate a float between 0 and 10 and store it. And we'll choose this drop-down menu. Now you can see that any variable that we've created is available. If we created a variable in the state machine, it'll be available in this list. I'll choose Y position. So in other words, we're generating a value between 0 and 10, and we're storing it in the Y position. So now what we'll do, in addition to that, we've stored that value. What we'll do is we'll also set the position of our spawn object each time we generate a new object. We're going to set our Y position to our new variable. So it could be something between 0 and 10. We don't know what it is. The computer's making the random number for us. We're just going to apply it. So we generated the random number. We stored it in a variable that we can now go back and reference. So what I'll do is I want to go back to my transform menu, because transform will allow us to set the position, the scale, the rotation. It'll allow us to get what the position, scale, and rotation is of objects. And if I look in here, we have the ability to set a position. Okay, so what I'll do is I'll just double click. And we want to set a position. We'll use the owner's game object, right? Because this is on the obstacle spawner. So we want to use the owner. We don't want a vector. We don't want to do this on the X value. We want to set it to the Y value. So this Y position, its new Y position is going to be whatever the value of the variable Y position float is. Okay, now you'll see I'm getting a 0 popping up under my Y. You're probably not getting that. That's just because I have this debug turned on. And what that will do is while we're running our application or our game, we'll see this value change based on whatever the value of Y position is. So as it changes, every time it waits and respawns, it should generate a new value here. So let's follow this logic through. So when this machine starts, it's going to create an object. Okay, so it's going to spawn our object from our prefabs. The next thing that it'll do is it will set the position of the spawner. Now, actually, I could probably move this around and have this stuff start at the top. And actually, when we look at this, it's probably not in the order that we want. It'll establish a random float. So a random float will be stored inside that Y position variable. When it's done with all of that stuff, it's going to wait X amount of seconds and then kick it back and redo all of this stuff again. Now, this might not seem like a logical flow of information. What seems to me that would be more logical would be that we create an object, we generate that random position, and then we apply that random position. Now, even more accurately, what we might want to do is establish the random position of our spawn object before it even creates an obstacle, in which case we'd want to move this down towards the end of the list. Now, it would still function properly the way that we had it before. The difference between moving this all the way down to the bottom is that it would inherit its first position, whatever this position is sitting in, it would create the object there first. So the first object would always be generated at the same position, which could be a good thing for the first level, could be a bad thing. But so let's test this now and see if this object works. Now remember, I'm going to go with my weighting. Every 4 seconds it's generating an object. I'm going to be a little impatient. I'm going to take that down to 2 or 3 seconds. That way I can see the result of this a little bit quicker. So I'm testing it. The first object is spawned down at the bottom. The next one spawns a little bit higher. The next one spawns much higher. It's going to push my player off the screen. That's okay. I'm just going to let this run a little while to see what other kinds of results that we have. So you can see that there's randomization here. Just kind of, we can't predict where this thing's going to move. We know that it's going to generate and move something every 3 seconds right now. And that is an interesting element in our gameplay. Now, one of the issues that we have is that we're spawning every 3 seconds, we're spawning an object. And these objects continue to move throughout space. And if we let this run, we're going to end up with, you know, tons of objects inside our scene. And this is stuff that Unity has to keep track of. In fact, if I go to the bottom of this list, you can see that this is the first object that's been spawned, and it's already at an X value of almost -100. So it's way off there in space. Unity is still tracking that. So that's a system resource that is being utilized that we could use better in other places. So we don't really care what happens to these obstacles once they get off screen. So in fact, what we could do is we could destroy that object once it gets off the stage. Okay? Now what we could do is we could wait a certain amount of time and then destroy that game object. But that wouldn't be kind of an appropriate universal application, because if my computer is running faster than your computer, we might have, you know, things unfolding at a different sense of time. And so what we'll do is we'll measure the X position of these obstacles, and based on how far this is or what its position is in space, we'll destroy that game object. So once we determine that we're certain that it's off screen, we'll destroy that game object. But we'll do that in the next presentation.